good evening everybody. We're now going to look at the next topic, which is marginal cost, marginal revenue, and marginal profit. Now, just a disclaimer, this video is for the integrated math students from the Navy's Sixth Form College. They have the handouts and will be following along. So, the revenue function represented by R of X is the total income from producing X units. The cost function expressed C of X is the total cost for producing X units. And the profit function P of X is the total income minus the total cost. If it is a loss, it will be the same formula, income minus cost, and can be expressed as L of X instead of P of X. Now, what actually is this marginal? The additional cost of producing one more unit is called the marginal cost. Marginal can be found from the derivative or from differentiating. And the expressions are R prime X for the marginal revenue, C prime X for the marginal cost, and P prime X for the marginal profit. Let's just look into an example to make things a little clearer. So, first example says the cost of producing X burgers per hour is given by the function C of X equal 1000 over X plus X for more than 35 burgers. Each burger costs $2.50. Find the marginal cost, marginal revenue, and marginal profit for producing 60 burgers. So, this function can be used to find the price to produce more than 35 burgers. Any amount of burger that exceeds 35. We'll use this function to find the cost. But we are not asked to find the cost. We want the marginal cost. So what we will do is differentiate our cost function to get C prime X. First, I rewrote this function by bringing up this X and raising it to a -1 to give me 1000X to the -1 plus X. So when I differentiate it, I will get -1000X raised to -2 plus 1, which can be also written as -1000 over X squared if this is brought down, and our plus 1 goes back. Now, we want the marginal cost for producing 60 burgers, meaning after making 60 burgers, if someone wants an extra burger, what's the additional cost? So we will simply plug 60 in this X area, and that will give us -1000 over 60 squared plus 1, which equals 72 cents. So after producing those 60 burgers, if someone wants one more burger, it will have an additional cost of 72 cents. Now for the next part, the marginal revenue. So that's the price of the item times the number of items. So the price was $2.50 and X is the amount of items. So this will give us our revenue function as $2.50X. So therefore, differentiating this function, we simply get 2.50. And then for the last part of the question, finding the marginal profit, it will be the marginal revenue minus the marginal cost. We found the marginal revenue as $2.50 and the marginal cost was 72 cents. So when we subtract that, the marginal profit will be $1.78. Now, let's look into another question. It says, a manufacturing company produces and sells tables. The cost function is given by C of X equals 4X plus 120 root X plus 4,000. If the tables are sold for $200 each, find the total cost of producing 36 tables. Now, here is our cost function, and we can use it to find the cost of any amount of tables. So we will simply plug 36 in place of the X to give us 4 times 36, 144, 120 times root 36, which is a 720, bring back our 4,000, and when we add all of this, the cost for producing or making those 36 tables is $4,864. The B part is asking for the revenue that you'll get from selling those 36 tables. So the revenue function is going to be the price times the amount of units. The price was $200 and the amount of units is 36. So when we multiply those, the income is going to be $7,200 for those 36 tables. The next part is asking for the profit, and the profit will simply be the income or the revenue minus the cost. The revenue was $7,200. The cost for producing the 36 table was $4,864, as we found earlier. So when we subtract that, there will be a profit of $2,336. Now for the C part, it's asking for the approximate cost for producing one more table after making 200. So this right here is referring to the marginal cost. So first we need the marginal function, the marginal cost function. So by differentiating the cost function that was given, we get 4 plus half times 120 is 60. Write back our x and subtract 1 from the power to get negative half. And differentiating this constant will simply be 0. So now we have our marginal cost function as 4 plus 60 over root x. This x to the negative half is same as 1 over root x. So that's what we'll get for our marginal function, 4 plus 60 over root x. So here I simply plug the value of x, which is 200 tables, giving us an answer of $8.24 for the marginal cost. So that is, to produce one more table after making 200, it's going to have an additional cost of $8.24. Part D is asking for the approximate profit after selling the 201st table. So the formula for the marginal profit is going to be R prime x minus C prime x. We found C prime x to be $8.24, so we need what? We need our R prime x. Now we know that the R of x function is 200x because the price is 200 and we need x amount of units. So when we differentiate that R of x function, we get R prime x to simply be 200. So going back to our formula or our function, 200 minus this $8.24 will give us a profit of $191.76. And now this last part is asking for the average cost per table for 200 tables. So we basically want to know, to make 200 tables, what's the cost going to be for each of them to make each. So back to our cost function, it's 4x plus 120 root x plus 4,000. So we will simply plug 200 in place of the x, and when we do that, we get $6,497.06. So this is the cost to make or produce 200 tables. So now we need the cost for each table. So we'll simply divide by 200, and that gives us $32.49. So basically, each table costs $32.49 to produce, and they are being sold for $200 each. Okay, let's look at our last question. It says, the cost of producing X cameras is given by C of X equals 10x plus 100 root x plus 10,000. Determine the marginal cost, marginal revenue, and the marginal profit for 400 cameras if the demand for the camera is given by 1,000 over root x. So first, marginal cost. We already have our cost function, so we will simply differentiate that to get C prime x. So this is our cost function, and when we differentiate, this 10x will give us 10. here half times 100 is 50, right back our x, subtract 1 from the power to get negative half, and differentiating this constant will give us a 0. So now the c prime x function is going to be 10 plus 50 over root x. So to find the marginal cost, we will simply plug 400 because there are 400 cameras, 400 in place of x, and that gives us an answer of $12.50. Now for the marginal revenue, so that's the cost, the price, times the amount of items. Now what we have here is the demand, and this we have a function here for the demand of the item. So we can use that and multiply by x, which is the number of items. So it's the demand times x, and we can simplify that. First, I rewrote this function as 1000x to the negative half by bringing up this root x. And when I multiply by x, rule is when we're multiplying, we add our powers. So that gives us 1000x to the half, because negative half plus 1 is a half. So this right here is the revenue function, 1000x to the half. So therefore, the marginal revenue, when I differentiate, will be 500x to the negative half, which is the same as 500 over root x. So therefore, I can now find the marginal revenue for 400 cameras. Oh my. Sorry about that. I think I'm going to start over. So the demand is 1000 over root x, and the amount of items, so it's the price times the amount of items. So when we multiply that, we simplify and get 1000x to the half, and therefore if we differentiate this revenue function, we get r prime x to be 500x to the negative half, which is the same as 500 over root x. So now if I plug 400 in place of this x and evaluate, I get $25 as the marginal revenue. And lastly, for the marginal profit, its formula is going to be the marginal revenue minus the marginal cost. We found the marginal revenue to be 25 and the marginal cost was $12.50. So when we subtract them, the marginal profit is $12.50.